Order, order. Good afternoon and welcome to the Environmental Audit Committee for our oral evidence session into our inquiry on climate change and food security. And we're very pleased to have two groups of witnesses today and two panels. We're joined in person by George Monbiot, and I just ask you very briefly, if you would, George, to explain your interest in this topic.
Thanks very much, Philip. Well, I'm a journalist and author. I wrote this book, Regenesis, Feeding the World Without Devouring the Planet. Food and farming has been an interest of mine for 30 or 40 years now because I see it as absolutely essential to the question of whether we're going to get through this century and those that follow.
Thank you very much. And we're joined on screen from Indiana by Professor James Lowenberg-DeBoer, who is a professor at Harper University in Shropshire, in the county which I represent. But perhaps, James, you could just also explain your interest in the topic.
Yes, I'm an agricultural economist. I've spent my career looking at the economics of new technology in agriculture. My students and I did much of the early economics work on precision agriculture in the 1990s, pursued that. One of the important things to note about me is that in addition to being professionally interested in the economics of precision agriculture, I'm also a farmer in the United States, and so I earn a considerable part of my income from agriculture every year, so I'm concerned about it both professionally and personally.
Well, we share that in common, not the academic aspect, but I should also declare that I'm also a farmer here in Shropshire and Herefordshire, where we grow livestock as well as cereals. And I am both a member of the CLA and the NFU, so to get that on the record as well. George, if I could start with you. We've obviously seen the consequence of conflict on food security over the last 12 months with Putin's invasion in Ukraine, but we also saw the impact of climate change with various fresh food products not being available in supermarkets in the UK this winter. You've written extensively, as you've said in your opening introduction, on this topic. Could you give us your reflection on the key challenges affecting our ability to secure the food that we need to continue to survive in the UK for the decades ahead?
Thank you. Well, as I'm sure you're all aware, we're becoming more and more cognizant of the huge threats now posed to the global food system by environmental change, but also by geopolitical shifts. But I would separate these out from an even greater threat to the global food system, which is the global food system. It is a system that is losing its resilience in a very similar way to how the global financial system was losing its resilience in the approach to 2008. And for very similar reasons. Extreme corporate concentration, similar strategies being pursued by the same corporations, synchronization, the loss of what systems theorists call modularity, in other words, a compartmentalization of the system. Everything flows into one as trade goes around the world. For all these reasons, as any systems theorist would point out, we are seeing a global food system which is already losing its resilience, and now it has to cope with ever more extreme environmental shocks, sometimes coupled with geopolitical shocks. A classic example of this was after Russia invaded Ukraine. The Indian government stepped forward and said, don't worry about the wheat shortfall, we're going to have a record harvest this year, we're going to become a super exporter. A month later, it came forward again and said, about that wheat harvest, there's been a huge heat wave, the grain has shriveled on the plants, and we're going to impose an export ban instead. And so we saw then an environmental crisis coming together with a geopolitical crisis. But it might not take a major push to shove this very fragile system past its tipping point. And the prospect of that is almost unthinkable. I mean, had the financial system gone down, we know it would have created global misery on a huge scale. But if the food system goes down, we're talking about an even more serious set of implications. And while governments were able to bail out the global financial system at the 11th hour by producing future money, you can't bail out the food system by producing future food.
Thank you. You've raised lots of interesting issues there. I'm sort of conscious that we've got quite a lot to get through quite quickly, so I'll come back to some of it later. But James, could you give me do you share George's concerns about resilience of the system, or do you have a different perspective on how food producers have been coping with increased demand through increased population over decades?
Absolutely. I agree completely with George's concern, even though I might suggest some additional solutions that he hasn't focused on. Two things that I would emphasize here. One of them is that resilience of any system, and this is in particular the food system, requires diversity. That if you depend on one or two or three sources of food, those can be easily disrupted, and history gives us ample examples of what happens if you depend too much on imports. Then disruption of imports by war or natural disaster causes a problem. If you depend only on corporate farms, then there are other issues that happen. So having a diverse food system with different kinds of producers, different kinds of farms with different specialties, different sizes in different parts of the country and in different parts of the world, it creates resilience. Secondly, I would like to emphasize the role of farmer livelihoods. If farmers can't support their families by producing food, then the whole food system is undermined. And I would like to remind the committee that in many ways, food security is a public good. Food itself is private. If you eat it, I can't eat it. But food security, the sense that the whole society is going to have enough food, is a social creation. And in particular, I have that experience from early in my career. I lived in the Sahel region of West Africa in the 1980s and 90s when it was very, very food insecure. And so even though my family and I, we were food secure, we lived in a society where many, many people were incredibly worried about where their next meal was coming from. And that creates a tension and it creates distortions that are felt by everyone, not just by them. Thank you.
Thank you. We had the example of the pandemic just before the conflagration in Eastern Europe, where a lot of agriculture was disrupted around the world. How would you characterise, George, that experience in terms of acting as an advance warning resilience? Did we see resilience breaking down in many economies? Actually,
the food system survived better than I would have anticipated. There were disruptions, and we did see sharp fluctuations in global food prices. We also saw more people going hungry. But it was pretty well in trend. It didn't have the enormous impact that we might have expected. You know, when the thing which tips the system over the brink is impossible to predict. You know, it can be the butterfly's wing. It can be a relatively small fluctuation, like the subprime crisis in the US tipped the financial system. It might be a very big disruption, but it almost certainly won't be the thing that we think it's going to be. Now, the really worrying trend here is that since 2015, the rate of global chronic hunger has been rising. And for the first 5 years of that rise, global food prices were historically low. So any economist will tell you, well, that's impossible. If food prices are low, fewer people will be hungry. But what we were seeing there is that a system that's lost its resilience starts transmitting shocks instead of damping them down, because a resilient, robust, complex system using negative feedback loops will damp down shocks. A system losing its resilience, those negative feedback loops will turn to positive ones. It will amplify shocks. Those shocks did not fall on us, the rich nations, because we were front of the queue. We had hard currencies, strong buying power, they hit the poor nations. And we saw local food price spikes even when the global price was low. But we should be just as worried about this situation as the poorer nations are, because this is what systems theorists call flickering. When you start seeing these apparently inexplicable fluctuations happening, that suggests you are close to a tipping point. Now, I've been reading the transcripts of previous hearings on this subject by the committee, and if I may be allowed a note of mild criticism, I'll say there's been too much focus on our national situation, and there's in some cases been a confusion between food security and food nationalism. And I know that Henry Dimbleby went to some lengths to say there's lots of different kinds of food security, and one is the U-boat food security where, it is food nationalism. But actually, the thing that threatens us far more than any other factor is the global system going down. And it's reading scientific papers now, going back 10 or 12 years, about the threats to the global system. You get the impression there's been no pickup of this at all. Not in politics, not in the media, anywhere in the world. It's as if the scientists are behind a sheet of plate glass and you can see their hands banging the glass, you can see their lips moving, you can't hear what they're saying. And it's a truly terrifying situation. I read over 5,000 papers when I was researching this book. The most frightening of all were the ones that related to the systemic fragility of the global food system, and no one's attending to that. We urgently need to.
One of the reasons we've been focused on the UK is because that's where the UK government is able to exert some influence. Internationally, we can exert influence through aid, we can exert influence through science and technological endeavour that we encourage here. So gene editing, for example, is one way of making crops more robust internationally. Do you think we're doing enough to try and export technological advance?
It's not just about that. It really isn't. I mean, this isn't just about producing more food. We produce a great deal of food. The average food available...
resistant varieties.
Yes, I mean, we certainly need all of that. We need, a great deal of innovation right across the board. But this is about something else. This is about the system itself, and the system operates on principles which are completely different from those that the committee's been discussing so far. They're the principles which affect all complex systems. And there's just been no recognition of this. I mean, a role that the UK could have would be to start that international conversation which urgently needs to be had.
James, you wanted to come in on that?
Yeah, back to the effect of the pandemic, that as far as I can see, there wasn't a lot of impact of the pandemic on production, except perhaps in fruit and vegetable production where labor was an issue. But where we saw the big impact and the big disruptions was in the supply chain, which could not adapt quickly enough. So we had dairy producers in the UK and in the US and elsewhere dumping milk, not because there wasn't a demand for milk, but because the processors were set up to serve certain markets in restaurants and catering establishments, not individual consumers. And so it took them some time. So the rigidities in the supply chain, and I think this reinforces what George has been saying about the fragility of the system, that cost cutting and tight margins encourage processors and retailers to focus on one or two key markets and key products without the flexibility to switch between them easily as it's needed.
Do you have some suggestions on what the UK can do, George, to improve resilience in the way that you've been describing internationally?
Yes, so there's 6 components of systemic resilience. One is diversity, and James has spoken about the urgent need to start diversifying our food systems, and there's a lot of interesting ways we can go. I mean, I'm fascinated by the potential of perennial grain crops, for example, which is beginning now to be realised. I'm also fascinated by the potential of precision fermentation, which can create an entirely different food system, because that's another of those elements, is a backup system, And then there's modularity, which I've mentioned. To what extent is systemic failure contagious? And if you can have firewalls within your system, as they tried to introduce to the banking system after 2008, you can prevent that contagion from spreading. You need circuit breakers, which is effective regulation, which again speaks to what James is talking about, and the regulation which can again prevent contagious collapse from happening. You need asynchronicity. You need to desynchronize the food system. The system's on a knife edge a lot of the time. 55% of global grain trade goes through a number of pinch points. Turkish Straits, Straits of Malacca, Bab el-Mandab, Straits of Hormuz, Suez Canal, Panama Canal. We've been amazingly lucky so far. The Ever Given got stuck across the Suez Canal in 2021. The Russian invasion of Ukraine was in 2022. Those two things have coincided. The food chain could have snapped for hundreds of millions of people. The shelves could have cleared. And everything is on a very, very narrow safety margin at the moment. So we need to desynchronize that. It's a huge program. It is required to turn this back into a resilient system. There's not a single policy which will do it. But I would be very happy to have further discussions with anyone who's interested in doing this, because it's just a different mindset which is required, a whole new way of thinking about what systemic resilience looks like.
But also difficult for us to influence the global food situation. I mean, the challenges of drought along the Nile impacting a country which has a population approaching twice the size of the UK now, not quite, but... Yeah.
No, well, of course this is true, but by starting to talk about it, I mean, this, as far as I know, is the first hearing in any legislature around the world which is discussing this issue.
I think you've just given us a headline. That's very, very good to hear. James, I think you wanted to come back, and then we're going to move on.
Yeah, I think it's important to mention here that technology gives us some new tools, and George has mentioned some of those new opportunities, but work at Harper Adams and elsewhere, particularly in the UK, has shown the potential for agricultural robotics and AI and Agri-Tech in general to better integrate natural systems and food production systems, so that in the past with mechanization that favored large, roughly rectangular fields and eliminating other kinds of hedgerows and infield trees and so on. With autonomous machinery, with AI, with Agri-Tech, we can do a much better job of integrating different kinds of crops and plants into the same kinds of systems, producing resilience, but also allowing room for biodiversity and all the benefits that brings with it. In this regard, the UK has some advantages. We're ahead in many ways on the research in this area. We're also ahead in what we can say is the regulatory sphere. That British Standards is about to come out with a code of practice for autonomous mobile crop equipment, which would provide a framework for the use of this technology. And in some places in the world, in the U.S. state of California and in the EU, there's been very rigid rules about how autonomous equipment might be used by farmers that in many cases make it economically infeasible. The rules that are coming out from British Standards, or the code of practice, which was produced by a stakeholder group, will facilitate that by providing guidance on how farmers might assess that risk. So there is a real role here that Britain is playing in creating an environment where this kind of technology can be effectively used.
I visited the robotic plant within Harper Adams' facilities, and part of the environmental land management scheme support for sustainable farming incentives is to encourage take-up of contemporary modern technology, including robotics. So do you think that that is a good example of how food security can be used as part of the new subsidy or support mechanisms for agriculture, public good for public money for public good?
I think it's a good start. Farmers need to start experimenting with this technology. And what always happens with new technology is that farmers discover ways to use it that were not evident to the original creators. They are much more familiar with the day-to-day reality of the problem. And so the new programs help move in that direction. If you asked me what the constraints are to really moving that technology into greater widespread use, it's really maybe two things. One of them is better business models. How can the agricultural sector take advantage of these new capabilities? If now labor is no longer the key binding constraint for most farmers, are there things that we can do, like mixed cropping, strip cropping, individual plant management, that we couldn't do in the past? And then how does that get to farmers? And this is an area where Britain has not been a shining example. The transfer of technology from science to farming in Britain has been less than many of its neighboring countries with similar circumstances, agricultural circumstances, France, Germany, Denmark, and certainly much less than in the U.S. or in New Zealand. And so there's really a need for a better pathway for science to reach agriculture and for agriculture to provide its feedback.
Thank you. Barry Gardiner.
Yes, I'd like to focus on the role of land use in food sustainability. Globally, we're projected to have to feed 2 billion more people within the next 30 years. And of course, the more land that we use for our own purposes, the less that is available, certainly the more we use for food, the less that is available for the other purposes that we benefit from, whether that be biodiversity or emission sequestration, whether it's simply recreation, horticulture. All of those other things, as well as other species, are going to be crowded out. How do we square that circle?
I'm really glad you asked me this, thank you, Barry, because land use is the crucial environmental metric, which is perennially neglected. We only really talk about land when it comes to urban sprawl. And urban sprawl is an important issue. It's bad for cities, it's bad for the countryside. But the entire urban area of the planet, all the homes, all the businesses, all the infrastructure is 1% of the land surface. Farming occupies 38% of the land surface. Of that, 12% is crops, of which roughly half that land is used to provide crops for animals. 26% is grazing for livestock. This is a tremendously profligate land use. It's mirrored in the UK, where 51% of the land is used for grazing or grass for livestock. It produces a very small proportion of our food, but it has a humongous ecological opportunity cost and carbon opportunity cost, because every hectare, as you say, that we use for our own purposes is a hectare that can't be used for other purposes. And the great majority of the world's wildlife species depend on wild ecosystems for their survival. Earth systems themselves depend on wild ecosystems for their survival. Now, it's already the case that the biomass of mammals on Earth, it consists of just 4% wild mammals, 36% humans, and 60% livestock. And yet, livestock populations are growing by 2.4% a year. This is a bit we can't afford. We could feed everyone extremely well on plants. We could feed everyone extremely well, incidentally, on single-celled organisms, which is where precision fermentation comes in. But there's just no good way of feeding everyone on livestock products, because there's just not enough planet on which to do it. And we've seen this great push by celebrity chefs and food writers saying, eat pasture-fed meat. We could eat pasture-fed meat if we had several planets and no space for wild ecosystems on any of them. And the global demand for pasture-fed meat is now driving the destruction of the Amazon. It seems to me the only way we're going to get through this century is through a major rewilding of both land and sea, to stop the sixth great extinction in its tracks and to draw down large amounts of carbon dioxide from the atmosphere. And that can only happen if we basically stop eating animal products. That's the thing which is preventing that transition from taking place. So the land issue is primarily an animal farming issue, but the land issue is also potentially the most important of all environmental issues and the most neglected. And it's high time we focus laser-like on that issue.
Thanks very much. Professor Lowenberg-DeBoer, you talked earlier in your response to the chairman about technological innovations and the application of science. To what extent could that increase the efficiency of the way we use land, both globally but also in the UK?
There's a very substantial potential, and my own work has focused much more on crop production than on livestock production. And in the crop production area, there's a major potential to use technology and data and analysis to intensify agriculture on and production on the land that we already use. So let's take the example of mixed cropping. In the U.S., there's good evidence that maize and soybean production can be increased somewhere around 15 to 20% by growing them in strips instead of in large field monocultures. And in the past, this was not possible because it required too much work. If you have autonomous equipment, if you have robotics, this all of a sudden changes and this becomes a possibility. And that's just an example. We need much more work in Europe and in the UK on how that can happen with European farming systems.
Are there not? Sorry to interrupt you, Professor, but are there not going to be very strong pushbacks from industry, from farming communities, where huge amounts of capital have been invested in machinery precisely to strip whole plains, to go towards a system such as you're talking about, where that would not be appropriate, where that equipment in effect would become redundant?
You're talking about a transition issue, and I think there will be at least two pathways for the adoption of autonomous equipment worldwide. There'll be one pathway in North America, in Australia, in Brazil, Argentina, places where there are large, basically rectangular fields, and we'll see a lot of co-robotics. And we're seeing this happen already. We're seeing the introduction, for instance, of smart grain carts, in which there still is a human operator in the combine harvester, but there's a smart grain cart that syncs itself and facilitates unloading. I think what will happen in much of Europe, in Asia, is autonomous equipment. And there, conventional machines have been used. And as we know, the size of tractors in the UK has been growing over time. And sometimes it surprises me how large equipment is used in relatively small fields, but that's what's available. So there's an opportunity there for something that comes in and fits the Northern European, Asian situation much better. So yes, there are transition issues, and there is resistance, and there always is in new technology from the old technology. But there are places where this will happen quicker and more slowly.
So you believe that it is possible to meet the biodiversity challenges that we face, the net zero challenges that we face, without removing some land from food production, even with that increased global population that's predicated.
Okay, and I think there are good reasons to think about changes in land use. So if we think about livestock production in the UK, with changes in the subsidy situation, many beef and sheep farms are unprofitable. There's reasons to think about, okay, should they change the way that they do business? There's changes in consumer preferences. That in some parts of the world, there's less demand for red meat than there was in the past. There's other issues around environmental carrying capacity for intensive livestock and willingness of society to tolerate that, animal welfare issues. So there's lots of reasons to rethink the use of land, and there may be some areas that are better off with other kinds of land uses in nature or in woodlands or in perennial trees, or if perennial grain crops are developed, that would be wonderful. So I think there's a reason to think about changes in land use, but there are also many opportunities within the current land use to better integrate natural systems. So instead of focusing on large fields with only a single monocrop, do we now have fields that have several different crops in them, and perhaps natural areas that are used as the areas that then serve as the host areas for predator insects and so on and so forth. So we can, with technology, better integrate nature and crop production.
Okay, thank you. George, you spoke about the bottlenecks in the system, the different straits, Bosphorus, Dardanelles, and so on. There are other bottlenecks in the system, though, and they're the companies that export that grain around the world. So you're talking about what, 4 major companies that control 90% of grain movements around the world. They also represent a bottleneck in the system in terms of food security and food supply. And if you look at the profit margins that they have been making, which I'm sure you have, and you've seen the evidence that was presented in Darius Sokolov's papers on that, you'll see that they have been making post-production profits, post-COVID profits, post-pandemic profits that are over 2,000 times higher than their pre-pandemic profits. So the way in which the system is conjoined is not just the bottlenecks geographically, but also financially. What does government have to do about that?
Yeah. Well, this is a very good point, because this introduces extreme systemic risk. They've become too big to fail, and we all know where that leads. And their synchronization of strategies, and they've been also integrating with the financial system, integrating with IT systems to enhance what systems theorists call the network density of the system. And the more dense the system becomes, the more fragile that system becomes. We urgently need, in this sector and in all others, to reintroduce strong antitrust laws and to weaken intellectual property rights. And those things have to go together, because what's been driving the mergers and acquisitions has been the demand to acquire more intellectual property rights, to basically control the food system horizontally and vertically from farm to fork. And this all adds to the danger that we face, not just systemic danger, I mean, this is possibly the greatest existential threat we face that unfortunately no one's talking about, the potential collapse of this system, which has been weakened by these corporate strategies, but also, of course, for the reasons you point out, driving food inflation. And governments have to govern. Governments have to step in and be interventionist. I mean, even those governments committed to free market theory surely can see that in a situation of monopoly like this, you cannot have anything approaching a free market. We need this in every sector, but we need more urgently in the food sector than in any others. We need to start breaking up the large corporations, and we need to limit the scope of what they can own.
Thank you. I want to move locally now to nationally. I know you wanted to remain globally, but the government's developing its own land use strategy, its own land use framework, rather. What principles would you like to see enshrined in that framework to make sure that we do get our land used effectively, efficiently and sustainably?
Yes. Well, as Henry Dimbleby pointed out to you, 20% of farmland in Britain produces just 3% of our food. Within that, there are areas which produce almost nothing. There's 1 sheep per hectare, 1 sheep per 2 hectares, in some cases 1 sheep per 10, which is unfortunately enough to prevent any trees from growing, because the sheep preferentially nibble out the tree seedlings as they're highly nutritious. So we're producing almost no food and almost no nature across vast areas of land. There's more trees per hectare in some inner London boroughs than there are in our uplands, including our national parks. It's a scandalous situation, and that's entirely an artefact of grazing. It's not the tree line. The altitudinal tree line in most of Britain would be at about 4,000 or 5,000 feet. It's entirely through grazing. So we have to have a much more rational use of land, and to say in areas which are so patently unproductive as the ones I'm talking about, that land is far better used for rewilding. It's far better used to produce nature. And in doing so, you can draw down very large amounts of carbon. According to the Climate Change Committee, Government's committee, switching from pasture to woodland in the UK means the sequestration of an extra 25 tonnes per hectare of carbon just below ground, let alone the carbon above ground in the form of the trees. We are one of the most nature-depleted nations on Earth, and the only way we're going to reverse that is to set aside large areas of land and sea for nature to do its thing, rather than being constantly knocked back by our highly unproductive production systems. Now, this vision contrasts starkly with that of the National Farmers Union, which is trying to get to net zero by means which are not just infeasible but actually disproven, including, I think it's 49% of its net zero commitment is going to come from BECCS, bioenergy with carbon capture and storage, which we know will not fly. Now, if you want to sequester carbon, and in some circumstances, particularly in anaerobic soils, actually store carbon, the best way to do it is to stop farming in certain areas. That is by far and away the most effective way of drawing down carbon. But it's also the most effective way of restoring ecosystems. And it's proven. It's a proven technology, rewilding, unlike the technologies on which the NFU and others rely.
Thanks so much, James. I saw you wanted to come back in, Professor. Fine. No.
Okay, thank you. Duncan, did you want to come in with a supplementary?
No, I was just agreeing, but I was going to come in on
Okay,
three.
Matt Smith.
Thank you, Chair. After world's global population suffers from severe water shortage at least 1 month a year, so water is obviously a huge part of the conversation we need to be having here. So I suppose my opening question is how much of a threat water insecurity and water pollution is globally to food security?
Thank you. I'm so glad you asked that. James quite rightly talked about the need to close the yield gap and to raise yields where they can be raised. But the problem is that very often requires irrigation, and we're already maxed out. I mean, 70% of the water we withdraw is withdrawn for agriculture. Many rivers now are ceasing to reach the sea. Lakes are shrinking. Groundwater supplies are dwindling. Saline water is being drawn into aquifers because of the depletion of fresh water. Anyone can see that we are beyond the limits of water use already. And yet a paper looking into what water use would be required to meet this requirement of closing the yield gap, it found we would need to increase global water use by 146%. We just can't do it. That water does not exist. And so, without attending to the water issue, everything else is a pipe dream. We're relying on something which isn't there. And we have a very dangerous situation indeed now with some of the most important irrigated areas, having no prospect of being able to continue. The Indus Valley, the largest irrigated area on Earth, divided primarily between two nuclear powers, with a third having a small part of it, some of the most unstable regions on Earth there. It's very, very hard to see how things are going to end well as water supplies diminish, because glaciers are retreating. Soon we'll see, instead of the extra flow you get from the melting, we'll see diminished flow because the resource isn't there anymore. And as demand for water, for agriculture, for homes and for industry in the Indus Valley increases, the prospect of water wars there is as real as the prospect of oil wars in the Middle East. And this is a phenomenally dangerous situation. But as we know, even in the UK now, we are seeing many farmers suffering from severe water stress. We know that the drier parts of the world are likely to become drier while the wetter parts become wetter. We know there's an escalating cycle of soil moisture loss, because as the ground dries out, it produces less evaporation, and so you get less moisture in the air, and then it dries out more, and on you go. And you can very quickly see mass aridification. One estimate suggests an extra 1 degree of global heating would dry out 32% of the land surface of the planet.
Can I draw, Josh, on the UK example? So obviously the River Wye catchment, what are the consequences of the changes there for food security in the UK?
Yeah, well, what the River Wye shows us is that no freshwater ecosystem can survive intensive livestock farming. We're seeing this one of the most protected rivers in Britain, one of the most celebrated rivers in Britain, effectively being turned into a sewer. And that's as a result of the chicken farms in the catchment primarily. 70% of the phosphorus coming into the catchment comes from agriculture, and it's primarily this intense concentration of chicken farms. And just as no terrestrial ecosystem can survive extensive livestock farming, no aquatic ecosystem can survive intensive livestock farming because of the throughput of nutrients. And we talk a lot about, we've got to become more self-reliant in chicken and pork in this country. All you're measuring there is the throughput of Brazilian and US soy and maize. It's as far as you can get from being self-reliant. You're just bringing in one product to turn into another. And those nutrients have to have somewhere to go. You're putting a very large amount of nutrients through highly concentrated populations of animals. There can be many tens of thousands of chickens in a single, I call them factories, a single giant steel shed. And the dung they produce has to go somewhere. It's a high volume, low value product, and so it's not going to go very far. So it's going to be spread in the catchment. And even if you don't dump it straight into the river, the effect is more or less the same. And the Wye is effectively dead now. I mean, the ecosystem there is anchored by ranunculus beds, water crowfoot, which has a similar role to mangroves in a tropical sea. The water crowfoot is where the fish breed, the invertebrates breed, where everything shelters. It's been eliminated from almost the entire main stem of the river by the microcellular algae whose blooms are stimulated by the nitrogen and phosphorus going into the water.
And do you think there's any way of mitigating against the nutrient pollution from this large number of poultry farms, or do you think it will just come down to a reduction in the number of poultry farms in the catchment?
I think the only sure way is drastically to reduce the number of farms. And once planning permission has been given for those farms, the rest is a tragedy foretold. Because those nutrients are going to seep into the water. There's been talk about creating fertilizer plants, pelletization plants, anaerobic digestion plants. It's so far all talk. It hasn't materialized. The economics are probably against it, so it might never materialize. But even those plants can create enormous problems. Anaerobic digestion is a huge water pollution problem. Both through leakage, and I witnessed what happened in a tributary of the Wye, the River Llinvi, which was completely wiped out twice, we believe, from leakage from an anaerobic digestion plant, but also spreading the digestate on fields. This is an even more concentrated source of nutrients, which has caused innumerable cases of diffuse pollution around the country.
Thank you. if I may, Professor, a quick final question, which is, so how much potential is there for precision irrigation and agriculture techniques to increase water efficiency and prevent agricultural water pollution, would you say?
So I was going to add that there's a great potential for technology to improve the use of water. Most of the water use worldwide, and George is correct that in much of the world, available water sources for irrigation are running out or drying up. Irrigation is threatened. But most of the world's irrigation is furrow or flood irrigation, which is very, very inefficient and is very, very hard to manage. There are systems out there that can do a much better job, both sprinkler systems and drip irrigation systems. They require some investment, but one of the key issues there is understanding how to manage this. So if you talk to center pivot manufacturers in the U.S. and elsewhere, they have systems which can manage water very effectively. They can put a drop of water exactly where you want it. The question is, where do you want it? And so farmers and irrigation management and the companies have been struggling with coming up with the algorithms that will then optimize that system. Now, that could make the use of agriculture irrigation water much more effective, and could reduce some of the pressure that George is talking about. In the UK, while irrigation is mostly an issue with horticulture, fruit and vegetable producers, and there are some producers that are running short of water, the traveling gun systems that are typically used are only slightly better than furrow and flood irrigation systems in terms of precision application. And so there are possible systems that could be used in the UK to improve the precision of irrigation, but to the best of my knowledge, they are not being widely.
Thank you, Professor.
Thank you, Kat. Just before I bring in Caroline, I think Duncan has a supplementary now.
I mean, the water scarcity comments that you made at the very beginning were really quite scary, really. I mean, with what you said. I mean, the east of England I think it's the worst area of the country that is depleted with its scarcity of water, and yet it's the area that grows the most food. Now, if you take the water resources management plans, which the water companies are putting together, why is it that some parts of the country have got huge surpluses in megalitres of water, Yorkshire water, for instance, yet my patch, which covers a huge area, Anglia water, seriously depleted? We cannot grow, we cannot run factories. I mean, 10% of the soft fruit market is grown in East Anglia. They simply don't have enough water to grow food. So what is it about these water resources management plans, and how important are they? And have we been incredibly lax in, for instance, looking at new technologies such as desalination plants, recognising the environmental issues that they have created, but essentially a lot of that can now start to be rectified? Because simply we are running out of water. How are we going to deal with that?
No, these are very good questions. On desalination first, it's expensive. It's a good way of producing drinking water in some places which are very short of it. But if you want to use it to produce irrigation water, food could become a lot more expensive.
Yeah.
I mean, maybe in future there will be much cheaper ways of doing it. Small modular reactors, for instance. I don't know. One thing I would really urge, and I think this has happened in East Anglia, and elsewhere in the world, is to pay attention to the irrigation efficiency paradox, which is a bit like the Jevons paradox in energy, which is that the more efficient you become, the more you end up using. And that's because, like with your berry crops in East Anglia, you say, oh, great, now water has become cheaper, it's become a smaller component of our overall cost, so we can grow more crops which require irrigation. So you expand your irrigated area. And we've seen a classic example of this in the Guadiana Basin in Spain, where they invested 600 million euros in reducing water use and ended up creating more water use. It's a total catastrophe, and it's because they didn't put controls on how the surplus water would then be used. So if you're going to improve your irrigation efficiency, you also need to bring in regulations which say this must not lead to an increase in water use, otherwise you create more of a problem than you started with.
It is so damaging because it's not just about agriculture, it's about the economic damage. If you cannot run factories or you cannot build houses for people because you simply cannot get enough water to it, which is what's happening in the east, that is incredibly damaging for the country.
And I know it's a major issue in North Norfolk where you represent. In fact, I've just come down from there this morning and seen it with my own eyes.
Thank you.
Thank you.
Thank you, Duncan. Caroline Lucas.
Thanks very much, Chair. My first question was to Professor Lowenberg-DeBoer. You'll have heard the calls for a reduction in livestock farming in order to rewild more land. Could you just clarify what your view is on that specifically, and whether you think there are any unintended consequences from reducing livestock farming?
I think there are many reasons to rethink livestock farming, but I think that if we think about land use planning, I think one of the key criteria should be multifunctionality. Great Britain is a relatively densely populated island with intensive use. Every hectare needs to be used in multiple different ways, and so thinking about what are the implications of rewilding or changing the livestock sector. There's issues around rural communities, both the economic and the cultural life of those communities. There's issues around farmer livelihoods. There's ecological issues, because if you remove grazing, then you change the ecology, and there are certain birds and insects and so on that are disadvantaged, and others that will come in. Do you greatly advantage? You have a different ecology without grazing, but would a different kind of grazing, a better controlled grazing, be a better issue? So thinking through the implications.
Do you think the answer to your question is yes? You're raising lots of questions. I'm trying to pin you down onto what you think. So do you think?
I think that it would be extreme to exclude livestock production totally. That I think, yes, there are good reasons to rethink in certain areas. Almost every farm has some areas, I think, as George has pointed out, that would be better off with in woodlands or in grasslands or some other natural system. But that needs to be done with a sensitivity to the local and regional and national.
Okay. So George, you're about to destroy the livelihoods of loads of farmers and completely change the local ecology. What's your defence?
Well, there will be transitions, and we've got to ensure that they're just transitions. And in fact, farming is in a much better place to have a just transition than virtually any other industry, because we're spending £3.4 billion a year in the UK on farm subsidies. We can simply pay people to do something differently. If you compare that to any other industry, such as my own, journalism, which is about to go down in flames thanks to AI, will no one think of the journalists? Nope, no one will. There's no one's proposing a just transition there. There isn't an easy way out. A lot of people are just going to be thrown out of work. With farming, you can say, instead of paying people to stay in livestock farming, which is effectively what we're doing, both with area payments and with some aspects of ELMS, we can pay them to get out of it, but do something else on the same land. And rewilding your land, if you pay farmers the same amount of money for rewilding, because rewilding is cheaper than chasing sheep over rain-sodden hills, which is actually very expensive and loss-making, farmers will end up with more money in their pockets than they do at the moment.
Okay, thank you. And you've encouraged the committee to think more globally, and I just wondered if there's anything more you might say around the dependency of the UK's meat and dairy sector on imported feed, and what impact that's having on biodiversity and climate.
Feed imports are creating devastating effects on the other side of the world. For instance, the Cerrado ecosystem in Brazil, an area the size of Spain, has been destroyed since the 1960s, as well as large chunks of the southern Amazon and Gran Chaco and other crucial ecosystems, in order to grow the soy, which is primarily used to feed livestock, particularly pigs and chickens, but also supplementary feed for cattle, sheep, and other livestock. And this not only wrecks terrestrial ecosystems, it's also causing quite analogous symptoms to those being felt by our rivers over here, because it creates a massive flush of nutrients. And we're seeing the great tributaries of the Amazon, such as the Tapajós, the Xingu, Tocantins, now channeling vast amounts of fertilizer and soil nutrients from these ploughed up soils into the Amazon and out into the Atlantic. And now for 6 months every year, we see one of the most spectacular unnatural phenomena on Earth, which is the formation of a continuous band of sargassum weed, fertilized by these nutrients, stretching all the way down the Gulf of Mexico, around much of the coast of South America, and right the way across the Atlantic to the shores of West Africa, all fertilized by this enormous flush of nutrients being generated by the demands of our livestock. So the teleconnections of this disastrous trade are just as important, or even more important, to focus on than the immediate impacts that we see in the UK.
And just a quick aside, at our last hearing, you might have noticed that Dairy UK
Yes.
claimed that the dairy industry is making a positive contribution towards global cooling. So we're all fine because it's reducing methane emissions. I just wondered if you might make a quick comment on that.
This is such a phenomenal misreading of the science that it can only be deliberate. When GWPE was converted to GWP star through the recalculations of methane's global heating impact at Oxford University, what it showed was that the long-term impact of methane in the atmosphere was smaller, but also that the short-term impact of methane in the atmosphere is comparatively greater. Now, we know in trying to prevent climate breakdown, we have to act as fast as possible. So the sources of greenhouse gases which can most quickly be removed are the ones that we should concentrate on first. The biggest source of anthropogenic methane on Earth is the livestock industry, particularly ruminant animals such as cattle and sheep. We urgently need to reduce the methane source from those ruminant animals. That would make a very significant impact on the future trajectory of global heating.
And you are an advocate, as you know, for reducing meat and dairy consumption by promoting alternative proteins. And I wondered if you could say which of those proteins you see holding the greatest advantage.
So I think the most exciting technology for me is precision fermentation, which is just really a refined form of brewing. For 12,000 years, we've been refining the cultivation of multicellular organisms, of plants and animals. And it's a very inefficient way of producing food, which smashes up an awful lot of planet. But we can produce protein and fat far more efficiently, with much less land use, much less water use, much less fertilizer use, by growing microbes in vats. Now, I know it doesn't sound very appealing, but the implications are extraordinary. And the potential dietary transformation can be as well. I was the first person on Earth outside the laboratory to eat a pancake made entirely from bacteria, a small flip for man, and it tasted just like a pancake. It was delicious. But there's an enormous potential range of far better substitutes for animal products that you can produce with microbes than you can produce with plants. Plants are actually a very poor means of producing substitutes for animal products. Microbes have far greater potential with far lower environmental cost.
Can I just put that last question, if there's time, to Professor Lowenberg-DeBoer? What's your response to that as a way forward, the precision fermentation?
In short, when I think precision fermentation will find a place in the market like many other food alternatives, but to me it sounds like more processing. And one of the things we're advised by nutritionists is to eat less processed food, eat things that are closer closer to nature. And so, yes, is it a possibility? Is it a part of the portfolio? Absolutely. I would hesitate to come to depend on that very greatly.
Thank you. Can I just very quickly put that back to...
Yes, actually, I think it can lead to far less processing, because you can basically tell bacteria to produce whatever you want them to. If you want long-chain omega-3s, you've got long-chain omega-3s. I visited a laboratory in Amsterdam recently which has discovered a bacterium which smells and tastes exactly of sausages. And if you multiply those, you can make sausages with far less processing than you require to make sausages out of pigs. Because you're just growing the raw material straight there in the vat. Plant-based substitutes for animal products require a lot of processing. Microbial ones, potentially much, much less.
But are they Lincolnshire or Cumberland sausages? Really important.
Thank you. Right, we're going to have our last questions from Clive Lewis.
Thank you, Chair. Professor Lowenberg, how can government facilitate a more rapid innovation in agriculture to meet things like food security, net zero, and the challenges of depleting biodiversity?
The conclusion of the Awareness of Science group that met with Lord Curry much of last year indicates that one of the key element is reducing the fragmentation in the process of transferring science and technology from laboratories and research to farms. That the UK is unusual among its other industrialized country competitors in having almost no public sector extension or farm advisory services. And while those services have diminished over time in many parts of the world, they still play in the US and other places a very crucial role in facilitating the overall system. And the UK doesn't have that. There's many organizations, nonprofits, for-profit organizations, businesses that are involved in technology transfer. Farmers are very wary because everybody's trying to sell them something. Somewhere there needs to be someone, a third-party evaluator and a facilitator that helps that occur. And so reducing the fragmentation is a key element in making UK farming more productive and helping it be more competitive in the world.
And what role do you see things like digital technology and precision agriculture? What kind of role could that play? Is there a role for that in terms of enhancing sustainability and the efficiency of farming?
Absolutely. That precision agriculture, broadly digital agriculture, has potential in reducing many of the problems that we've talked about today in terms of reducing water pollution by applying fertilizers in the right amount, at the right time, in the right quantities, in the right place, rather than just broadcasting them. Similarly with pesticides, there's a great possibility of using this technology, but that technology will only be used if it is part of profitable farming systems. And up until this point, there's been a few things that have been widely adopted. So autosteer, for instance, is being adopted in Britain and everywhere in the world where there's mechanized systems because the benefits are easy to see and evaluate. Other technologies have faced much more resistance, in part because there are technical issues. Sometimes they don't work quite as well as promised, but also because there are economic issues in terms of how much they cost versus the benefit, how much farmers are recognized for the public good aspects of what they do. So there's a great potential for the technology, but getting it into the hands of farmers in the right form is key.
Thank you, Professor Lowenberg. George, you've been talking about germ sausages, not German sausages, and bacteria-made pancakes, although I think I've had a few of them myself in my time. What other alternative agricultural techniques are there that you're aware of and that there's clear evidence that they can help us capture carbon, enhance biodiversity, and restore soil health?
I would like, if I may, to go back to something I mentioned very briefly, which is the potential of perennial grain crops. Almost all our grain crops on Earth today are annual crops. Large areas covered by annual crops are rare in nature. They generally happen in the aftermath of a disaster, like a volcanic eruption or a major fire or a landslip, and the annuals can quickly colonize before they get shaded out again by the perennials. So in order to grow our annual crops, we had to create a disaster every year. And we had to clear the land, either by ploughing it or spraying it, and start all over with a lot of nutrients, a lot of pesticides, often a lot of water, to get those seedlings going, and we pamper them until they reach maturity, and then we start the whole process again. If you can grow perennial grain crops instead, which can stay in the soil for several years at a time, you can massively reduce nearly all the inputs and impacts of arable farming. And there's a group called the Land Institute in Salina, Kansas, which has been, with other organizations, scanning thousands of potential candidates with, so far, some great successes. In fact, in conjunction with the University of Yunnan in China, they've produced a short grain rice variety with the romantic name of PR23, which was actually a simple cross between annual short grain rice and a wild relative. And that's now been grown across several thousand hectares of land in China. The farmers are desperate for the seed because they've got a major labour shortage there. So many young people have moved to the cities. You need far less labour to grow it. You also need far cheaper inputs. You need less fertiliser, you need less pesticide, you need less water. The roots get well established. They can feed themselves to a large extent on water and nutrients. And it deals with the huge soil erosion crisis they've got in Yunnan, with terraces collapsing and the rest of it, because you're not ploughing so often, and the roots can help bind the soil. You've got much bigger, more robust plants with much deeper roots. And the Land Institute has found that some of its cultivars are actually far more resilient to environmental shocks as well. So, for example, it was growing perennial sunflowers beside a control crop of annual sunflowers that got hit by a major drought. The annuals were completely wiped out, and the perennials sailed through it because they had deeper roots and tougher above-ground structure.
Can I ask, was precision technology, precision and genetic technology used to splice those two together, or was it done through more?
They're doing it without genetic modification at the moment, so that they can sell it into the European Union if they so wish. So it's all what's called conventional breeding, though conventional breeding has now become extremely complicated and technical. But they could, in theory, speed it up with genetic modification. The really shocking thing to my eye is that this is basically being left to an NGO. This tremendous world-changing technology is being run out of a small farmhouse in Salina, Kansas. This is something that government should be getting behind. There could be great potential for perennial crops in Britain, but if crops aren't being specifically developed for the British context, then that potential might be stifled. I would love to see an intense research programme on this sponsored by governments.
And on a more kind of general note, you do seem, you're clearly identified as someone who's been at the forefront of warning us about the climate crisis. You're seen as an environmentalist. You do seem to be someone that embraces cutting-edge technologies, as opposed to perhaps sometimes more natural methods. I know you've made an analogy between kind of climate protesters siding with fossil fuel companies in some of the ways that some of the people and the NGOs and others look at that new technology. Do you want to talk us a little bit through that? Because you are kind of unique, not unique, but you you kind of don't fit into a box when it comes.
No. There is, I think, a regrettable neophobia in parts of the environmental movement. I mean, I know people who won't have a microwave oven in the house, but they do have a wood-burning stove. The one will not kill them, the other one might very well do so. And it's the microwave oven's nasty because it's new, and the wood-burning stove is fine because it's old. And we have a similar thing with our fetishization, particularly of pastoralism, of grass-fed meat, which a lot of environmentalists will get behind, even though it's the most damaging of all food products because of its enormous land demand and the huge ecological and carbon opportunity costs introduced by the conversion of wild ecosystems into pasture, or the failure to convert pasture back into wild ecosystems. And we really have to get beyond this. We have to put aside childish things and see how, just as in energy, new energy technologies, be it solar, be it wind, be it small modular reactors, be it geothermal, offer us a way out of fossil fuels. New food technologies can offer us a way out of the most damaging impacts of all, which are those introduced by the food production system. I mean, food production is the top cause of habitat destruction, of wildlife loss, of species extinction, of soil degradation, of freshwater use, of land use, and one of the top causes of climate breakdown, of freshwater pollution and air pollution. And we urgently need to attend to it, just as urgently as we need to attend to the issue of fossil fuels. But unless we develop the necessary technologies which make it easy for us to substitute the most damaging products, then we make it much, much harder for ourselves. So one of the things I'm trying to do is to dissuade environmentalists from standing in the way of some of the more promising technologies.
George Monbiot, thank you very much.
Thank you, Clive. Sorry. Just one other question I'd like to finish with, which is about the measurement and metrics. The government has got a food data transparency partnership here in the UK being established. Do you think that this is going to provide some answers to the questions about the impact of natural capital? I mean, you've made some pretty bold claims, George, about the damage of pasture-fed grass and the benefits of rewilding. How are we going to measure the impact on nature and food production if we take large swathes of current grassland which can't do anything other than raise livestock into rewilding? It has to be measured in some way to be able to prove that it has the benefits that you describe.
Yes, well, we certainly need better metrics right across the board. One of them is soil carbon. At the moment, our means of discerning soil carbon are extremely crude. Too crude, really, to give us reliable readings for changes from year to year. We need a great investment in soil science right across the board. Soil is more or less a black box to us, yet we produce 99% of our calories from it. And so I'm very much in favour of better metrics. I would strongly challenge your contention that the only thing you can do with pasture land is to raise meat in it. Rewilding is something you can do, and rewilding is a great benefit to humanity as well as to the natural world because of its potential to help stop the collapse of our life support systems. Nothing is more important than that. And there's a danger of falling into this sort of productivist mindset. The only thing you can do on a piece of land is production. Actually, sometimes a far more productive use of that land, if I can sort of adapt that term, is to stop trying to produce a very small amount of food in it and instead allow nature to flourish, which then allows humanity to flourish.
Albeit that we currently import 50% of our food, so we're going to have to, unless we adopt your new technologies to replace that food, which I guess is your argument,
yes,
it's going to take some time to do that, and whether we can do that in time, I think is quite an open question. I'm going to ask James just on this question of measurement and metrics and soil. I know Harper Adams have done a lot of work looking at the different types of measuring soil, and I'm interested in whether you agree with George that it's in its infancy at the moment.
I agree that we need a lot more work on soil science and agricultural science in general. In particular, we need cost-effective ways to measure environmental indicators using remote sensing, using other kinds of technology that would give us better widespread indicators instead of just taking a sample here and there. So I agree completely.
Okay. Well, I'd like to conclude that panel. Thank you very much to our panelists, George Monbiot and James Lowenberg-DeBoer, for joining us from Indiana.